Hello everyone, good morning. So today's my topic is framing. So let's start what is framing in computer network. So let's begin. What is framing? Framing is a function of data link layer which is layer of OSI model and it is second layer of OSI model. It involves dividing a continuous stream of data into manageable data units called the frames or transmission. So framing happens at data link layer, which is layer 2 of OSI module. It takes a long stream of data and breaks it into a smaller parts and called the frames. This makes it easier to manage, send and detect errors in the data. So the next one is why framing is needed. So framing is needed for synchronization, error detection, flow control and addressing. So what is synchronization? Synchronization helps to receiver understand where each frame starts or ends. Error detection. Frames include checksums or detecting transmission errors. Flow control. It ensures sender doesn't overwhelm the receiver. Addressing, it adds source and destination MAC address for proper delivery. So framing is important for several reasons. First, it helps with synchronization, so the receiver knows where each frame starts and ends. Second, it supports error detection by adding checksums. Third, it helps with flow control, making sure the receiver isn't overloaded. And finally, it provides addressing using MAC addresses so that reaches the right destination. Next one is a frame synchronization technique, and in that first one is a internal synchronization. So internal synchronization uses special bit pattern, flag or delimiter within the data stream to mark the beginning and end of frame. For the more explanation, frame boundaries are detected by scanning the bit stream for predefined start and end markers like 0, 1, 1, 1, 1, 1, 1, 0 in HDLC. If the delimiter appear in actual data, techniques like bit stuffing or byte stuffing are used to prevent confusion. This method allows support for variable length frames. So the frame synchronization is done using special patterns in the data like flags or delimiters. A common example of bit pattern is 0, 1, 1, 1, 1, 1, 1, 0 in HDLC. If the pattern appears in the actual data, we use bit stuffing or byte stuffing to avoid confusion. This technique also supports frame of different lengths. So the next one is the external synchronization. In that, it uses external clock signal to maintain timing alignment between sender and receiver. The sender and receiver operate on synchronized clocks, often using hardware timing mechanism. Frame boundaries are infrared based on the time intervals, fixed length time slots, common in a time division multiplexing TDM system where each time slots correspond to a particular frame or channel. So the external synchronization relies on synchronized clocks between the sender and receiver. Frame boundaries are not marked in a data but are based on a fixed time intervals. This method is used in TDM systems where each time slot is assigned to a specific frame or channel. So the next one is a type of framing in CN. So the first one is a character count. The first field of the frame specifies total number of character bytes in a frame. The receiver uses count to determine where the frame ends. So in a character count method, the first part of the frame tells how many characters the frame contains. Means the frame contains how many characters. The receiver uses this number to know where the frame ends. Receiver uses this number for the where the frame ends. It's simple method and easy to implement. Next one is a character stuffing byte oriented framing. It uses special character to denote the start and end of frame. If this special character appear in a data, an escape character DLE is added before them. This is a stuffing. So character stuffing is a byte oriented method. It uses special character combines like DLESTX and DLEETX to show the start and end of frame. If these special characters appear in actual data, we insert an escape character like DLE before them. This makes it easy to detect where each frame begins and ends. Next one is a error detection in framing method. In that, parity bit is a main one. So purpose of parity bit, it detects single bit error. And how it works, it adds an extra bit, parity bit, to make the number of ones. Either it is even or either it is odd parity. So one simple method of error detection is a parity bit. We add an extra bit to the data, so the total number of ones is either even or odd, depending on a parity rules. For example, in the data 0 1 0 1 0 0 1, we have 3 ones. To make it even parities, we add 1 at a end, making it 1 0 1 0 0 0 1 1. It helps detect single bit error during transmission. So the next one is a summary of the framing topic. So framing is a crucial for reliable data transfer. It defines how data is packed and detected and protected. A different method offer trend of efficiency, complexity and error tolerance. So to sum up, framing is essential for reliable communication networks. It determines how data is packed and how frames are recognized and how errors are detected. Each framing method has its own advantage and trends of. Some are simpler, others are better at handling error or more efficient. Choosing the right one depends on system needs. So this is our framing. So thank you.